Hello, I'm Mr. Huber, and I'm back with another math video. This one is for Algebra 2. It's your Unit 4, Quest 1 remediation sheets. All right, so let's go ahead and take a look at this now, and we'll kind of quickly go through this together. And then if you have any other questions, you can feel free to ask me those. All right, here's our remediation sheet. So our first target on here is I can factor quadratic expressions. All right, now I might not teach factoring exactly the same way that your teacher did, but just kind of over my teaching experience, this is kind of the way that I see students learn factoring the best. So I like to teach it using the X method. All right, so our first problem is x squared minus 3x minus 18. All right, so using the X method, I like to draw my X. We always multiply to the top here and we add to the bottom. All right, now in each problem, we are going to find our A, B, and C value. All right, so A value goes with your X squared, and it's that leading coefficient or that number before your X squared, which in this case, there is no number before that X squared. But really, we know that there's a hidden 1. It is 1x squared. That is our A value. Our B value goes with your X variable. So your B value in this case, and be careful because this negative goes with it. So our B value would be -3. And then our C value is this constant or just a regular old number. All right, and watch out. This minus sign also goes with that C value. All right, so it'd be a -18 for that C value. All right, now we always multiply to our A value times our C value. And then we add to our B value. All right, so in this problem here, A times C, well, your A value is 1 times our C value of -18. 1 times -18 should give us that we are going to multiply to -18. All right, and then we add to our B value, which our B value in this case we said is -3. All right, so that's kind of our original setup. So my next step is I'm going to make a T-chart of the factors of 18 to give me everything that I could use to multiply to 18. So I'm going to say, okay, factors of 18. Well, you could do 1 times 18. That's 18. We could do 2 times 9. Or we could do 3 times 6. All right, all of those factors would multiply to 18. All right, but watch out. We actually want to multiply to a -18. So that means one of our factors is positive and one is negative. So that means we're actually going to look at the difference between them. And we want the difference to be 3 or -3. Okay, so I look at these. The difference between these two is 17. The difference between these two is 7. And the difference between these two is 3, right? So I'm like, ooh, I'm thinking that these factors are going to be 3 and 6. All right, but again, I have to make one of these negative. Notice that it has to add, so these two have to add to a -3. So I actually want to make this a -6 because when I do -6 plus 3, that's going to give me -3. All right, and that's kind of how we do our factoring. Now, your last step is we want to put both of these over your A value, which remember our A value in this one is 1. So I'm going to put both of them over 1. All right. And then to write our answer, we always write from the bottom to the top. All right. So in this one here, bottom to top. So this would be 1x plus 3. Bottom to top, this would be 1x minus 6. Now, do you have to write 1x? No, you do not. All right. So we could really just write x plus 3, x minus 6. All right. And this would be factored. All right. And that's all there is to it. But it gets a little harder in number 2 because when we label our A, B, and C value, A is 6. It's not 1 this time, which makes it a little bit trickier, but we follow the exact same steps. All right. B value is 13 and C value is -5. So we still want to draw our X, multiply to the top, add to the bottom. Multiply to A times C. So in this case, that would be 6 times -5. So that gives me -30. And then we add to our B value, which is 13. All right, so now let's start listing out some factors of 30. So I have 1 times 30, 2 times 15, 3 times 10, 5 times 6. I think that's all of our factors. All right, now notice we actually want it to be a negative. Okay, so that means one is going to be negative, one is going to be positive. So again, that means we look at the difference. Okay, we want to look at the difference between the two factors. So this difference would be 29. This difference would be 13. So I'm like, ooh, all right, 13, that's what I'm looking for, right? Okay, now this confuses a lot of people because if you add these two together, that makes 13. But then they would both be positive, so they wouldn't multiply to a -30. It would be a positive 30. So we actually want to look at 2 and 15. So let's go ahead and write those in. 2 and 15. All right, now we have to make one of them negative. Notice this is a positive 13. So I'm going to make this a -2 because -2 plus 15 is positive 13. All right, and our last step is just to put them both over our A value, which our A value here is 6. So I put them both over 6. Now watch out, because in this example, they were over 1, so we could not simplify. This one, we have to simplify actually both of these. So I'm going to, on this side, divide my numerator and denominator by 2. So this would give me -1, and 6 divided by 2 is 3. And on this side, I'm going to divide both of these by 3. So I get 5 over 2. And our last step is just write your completed factored form. We write from the bottom to the top. So I would have 3x minus 1, and then 2x plus 5. And this would be our factored form. So you can see there was one extra little step at the end where we had to simplify when that leading coefficient or that A value is not 1. All right, but pretty much the exact same steps in numbers 1 and 2, which is why I like using that X method. All right, let's try number 3. Number 3, I draw my X. I'm going to label A value, B value, C value. We multiply to the top, add to the bottom. All right, your top is always A times C. So in this case, that's 1 times 27, which is just 27. We add to our B value, which is a positive 12. All right, let's list out our factors of 27. There's not many, 1 and 27, 3 and 9. I think that's it. All right, and now notice these are both positive. So both of our factors are going to be positive. So we're actually going to add the two together. So notice 3 plus 9 is 12. So I'm going to plug in 3 and 9. All right, these multiplied to 27 adds to 12. So we don't have to make either of them negative. And our last step is just to put them both over that A value, which in this case is 1. And now we just read from the bottom to the top. So I have 1x plus 3 and 1x plus 9. Now, again, do we need that 1? No, not really. So I could get rid of those ones. And here's factored form. But now when we run into something like number 4, you'll notice we still have an x squared term and we have a constant. However, we don't have an x term. See how it was always x squared x constant? We're missing an x term. So this usually signifies difference of squares. All right, and difference of squares says that, hey, you know what? We can take the square root of both of these. All right, so if we're writing it in factored form here, we're going to do the square root of 9x squared. So the square root of 9 is just 3. And the square root of x squared is just x. All right, then we do the square root of 1, which the square root of 1 is nice and easy. It's just 1 because 1 times 1 is 1. Okay, and now the difference of squares says, hey, to cancel out that x term, because we don't have an x term in this one, we make one of these addition and one of these subtraction. All right, now you might be wondering, well, why? Why do we do that? All right, and I'm going to show you. So this is our factored form. So we already completed this problem. All right, but let me show you why we do that. All right, we do that because watch what happens when I FOIL this. All right, remember FOIL stands for first. So I multiply these first two. So 3x times 3x is going to give me 9x squared. Outside, so our outside 2 would be 3x times negative 1, which would be a negative 3x. Inside, so our inside 2 would be this 1 times 3x. So that would give me a positive 3x. And then last. So last would be 1 times negative 1, which would give me negative 1. Okay, so when I FOIL this, notice I get this right here. And we can see, well, this negative 3x and this positive 3x would cancel out. And that's how we get that difference of squares, which this is the problem that we started with right over here. So that's why this would be our factored form. All right, so hopefully that made sense. And let's look at the last one in this first target. It says when factoring x squared minus 4x minus 12, what does your factors have to add to? So again, I like to draw my x, multiply to the top, add to the bottom. Multiply is always our a value times our c value. So 1 times negative 12 would give me negative 12. And we always add to our b value, which, be careful, in this case is negative. So I would say negative 4. So we would have to add to negative 4. All right, and that is it for our first target. Moving right along, we will move into target number 3. Target number 3 says I can simplify a radical expression using real and imaginary numbers. Okay, so what I like to do for this is I like to have a list of all of my perfect squares. So what's a perfect square? Well, a perfect square just goes to all of our numbers. So like 1 times 1 is 1. So that would be a perfect square. 2 times 2 is 4. So 4 is a perfect square. All right, so let's go ahead and go through all of these. 1 squared is just 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196, and 15 squared is 225. I stopped at 15 just because I don't think we'll need to go any higher than 15, and that's all the ones that I know off the top of my head. All right, but let's use these to answer some questions. All right, so it says, what perfect square could we use to simplify the square root of 147? So here's how I teach this, okay? Look at what you're trying to simplify. See this 147? Go to your perfect squares list that we just made and find the first perfect square that is less than 147. So I go, okay, less than 147 would be 144 right here. Okay, and for this part, you're going to need your calculator, which I know you guys all have calculators. You can just use the one that's right on your phone. All right, and what I'm going to type into that calculator is going to be 147 divided by 144. Okay, so go ahead, type that in, 147 divided by 144. Ooh, not so nice of an answer. I got like 1.020833333. Okay, if you get it any sort of decimal, that is not the one we want. And then we move to the next one. So now I'm going to do 147 divided by 121. 147 divided by 121 is 1.214. Nope, that one doesn't work. I'm going to do 147 divided by 100. 147 divided by 100, still a decimal. Nope. I'm going to do 147 divided by 81. 147 divided by 81 is still a decimal. Nope. Let's try 64. 147 divided by 64. 147 divided by 64. Nope. Let's try 49. 147 divided by 49. 147 divided by 49. Ooh, I got a nice number. All right, we found something that we can use to simplify this. When I did my division, I got 3. So that means that 49 times 3 is 147. So that's what I'm going to use to simplify this. So instead of writing it as the square root of 147, I'm instead going to write it as the square root of, we said, what, 49 times the square root of 3, because 49 times 3 is 147. Now, why do we do this? Okay, because now we have 2 radicals. It almost looks trickier. Well, watch out. We know the square root of 147, right? Because, did I say 47? 49, sorry. We know the square root of 49 is 7, right? So I can just simplify this to say square root of 49 is 7, and then we're going to multiply by that square root of 3. Now we don't want to change that square root of 3 because that's not a nice number. And notice this is pretty simplified. Okay, if we were to look at something like this, square root of 147, we're like, ooh, that's kind of scary. That's a big number. But when we look at just 7 times the square root of 3, that's much nicer. It's much smaller numbers, which is what we're trying to do. We're trying to simplify it. All right, so that would be how we simplify. All right, let's go ahead and erase my work on this one. All right, and then let's take a look at this one. So now we have 5 times the square root of 99. Okay, so we go 99, find the first perfect square that is less than 99. The first one that is less than 99 would be 81. So I can do 99 divided by 81. 99 divided by 81 is 1.22222. Nope, that doesn't work. What about 99 divided by 64? Nope. 99 divided by 49? Nope. 99 divided by 36? Nope. 99 divided by 25? Nope. 99 divided by 16? Still no. 99 divided by 9? Ooh, we found one. All right, so I have 99 divided by 9 is equal to 11. So that means 9 times 11 is 99. So I come down here and we're going to rewrite this as 5 times the square root of 9 times 11. Because remember, we said 9 times 11 is 99. All right, but now we can simplify this because we know what the square root of 9 is. The square root of 9 is 3. All right, so I'm just going to write 5 times 3 times square root 11. All right, but then we can actually do 5 times 3. 5 times 3, everybody knows that one, right? 5 times 3 is 15 times the square root of 11. And now we simplified that radical. All right, number 8, we have this square root of negative 64. Now watch out, we can't do the square root of negative numbers. Okay, that's what we call imaginary solutions. All right, so don't type them into your calculator because your calculator won't give you an answer. All right, instead, what we want to do is we want to pull out that negative. So I'm going to say, okay, well, this is really the square root of negative 1 times the square root of 64. Okay, see how I pulled that negative out? All right, now very important, the square root of negative 1 is equal to I. I is imaginary. So I can just say, okay, the square root of negative 1, we know that that's imaginary, times the square root of 64. So I come up to my perfect squares, and we'll notice, hey, wait a second, 64 is a perfect square. That means taking the square root is easy peasy. We're excited. We're like, yes, we don't have to simplify this because it's a perfect square. All I have to do is say, okay, square root of 64 is 8. So I come back down here and I would say 8. So you could write I times 8, or usually you'll see this written as 8I. All right, but we did it. That would be your answer for number 8, just that 8I. All right, I think we have one more in target 3. Okay, so this one is the square root of negative 48. All right, so again, let's take out that negative right away. So I'm going to say square root of negative 1 times the square root of now positive 48. Okay, now 48, unfortunately, is not one of our perfect squares. So let's go ahead and erase some of these x's. So notice 49 is, so we were super close, but nope, that means we have to try to simplify it. Okay, so first number less than 48 would be this 36. So let's try this. Let's do 48 divided by 36 and see if that works. 48 divided by 36, I got 1.33333. So no, that one would not work. What about 48 divided by 25? Still no. What about 48 divided by 16? 48 divided by 16. Ooh, I got 3. So that means that 16 times 3 is 48. So I'm going to come back down here and I'm going to say, okay, well, this 48, I'm really going to replace that with 16 times 3. Now, why? Why are we doing this? Why did we replace it with 16 times 3? Okay, well, because we know what the square root of 16 is, because it's a nice perfect square. So I say 16, the square root is 4. All right, so square root of -1 is I. Square root of 16 is 4. And then we just leave that square root of 3 because that's not a nice number. All right, so we could either write it like this or we could say 4I root 3. This is usually how you'll see it written with that I after. All right. Then that completes our target number 3. And then let's take a look at target number 5. Target 4, sorry.